Wouldn't it be great to know whether you're going to get real number solutions versus non-real number solutions when solving a quadratic equation using the quadratic formula? Of course it would, and that's exactly what this video is going to discuss. There's a certain part of the quadratic formula known as the discriminant that can predict in advance what kinds of solutions we're going to get should we solve the quadratic equation. And the discriminant is defined as the inside part of the square root when looking at the quadratic formula, in particular b squared minus 4ac. Now, we know that we just plug in the values of a, b, and c from the quadratic equation itself to help us evaluate this expression, as well as the different parts of the quadratic formula. But when you have your values of a, b, and c, this expression can turn into one of three types of numbers. It's called the law of trichotomy. You're either going to have a number that's positive, a number that's equal to 0, or a number that's negative. And so we have three cases that we can land in depending on the values of a, b, and c, and that's what is spotlighted in this box here. In the first case, if b squared minus 4ac is greater than 0, in other words, it's a positive number, then it's going to have two unequal real solutions. So your answers for x are going to be real numbers, but they're going to be different from each other. If it turns out that b squared minus 4ac is exactly equal to 0, then the equation is going to have a repeated real solution or a double root. So you're going to get real number answers for x, but they're going to be the same. It's like x equals 5 and x equals 5. If the discriminant is negative or less than 0, you're not going to get any real number solutions.
Nope.
Instead, you're going to get two complex solutions that are not real, or non-real as we'd say. And as an added bonus, they're going to be conjugates of each other. From a graphing perspective, if b squared minus 4ac is greater than 0, then the graph that corresponds to the quadratic equation we're working with is going to yield a parabola that's going to cross the x-axis in two different spots. If the discriminant winds up equaling 0, then the graph that corresponds to the quadratic equation we're working with is going to involve a parabola that touches the x-axis. So there's just going to be like one spot where it looks like the parabola is intersecting the x-axis. Whereas if the discriminant is negative or less than 0, that's going to yield a parabola that doesn't do anything to the x-axis. It's not going to cross or touch it. So with all this in mind, I'd like us to work on this example here in this video. It says predict the character of the solutions of the quadratic equation, and wants us to verify the answer using a graphing utility. So first of all, I want to point out that this equation, the quadratic equation, is in standard form. And for that reason, we're going to need values of a, b, and c. So let's pluck those out. Value of a is 1. That's the coefficient of x squared. Value of b is negative 3. And then the value of c is 4. We're going to use the discriminant to help us with this, b squared minus 4ac. And like I do with the quadratic formula, I'd like to go ahead and kind of scaffold this with a set of parentheses anywhere that there's a variable. And inside each of these parentheses are going to go the corresponding values of those variables. So for instance, the value of b is negative 3, so negative 3 quantity squared, minus 4 times the value of a, which is 1, and then the value of c, which is 4. So this is shaping up to be 9 minus 16, which is equal to negative 7. Now what does this all mean? Well, in terms of the sign of b squared minus 4ac, we have a negative number. So the value of b squared minus 4ac is less than 0. And what this means, based on what's in the box up there, is that we have two complex solutions that are non-real or not real. You can kind of write that more succinctly by writing this out. We're going to say that we have two non-real solutions. So if we were to solve this quadratic equation, which I definitely encourage you to do, you would see that our answers involve the imaginary unit I. And, moreover, they're going to be conjugates of each other. So that takes care of the first part of the problem, where they want us to predict the character of the solutions. All right, so to state that the solutions are non-real solutions is to state the character of the solutions. All right, so that's what it means by character. What kinds of solutions are we going to get? The second part is to verify using the graphing utility, and I'll write out the steps that you would take in order to do that. In your y equals menu in y1, you would enter in the left-hand side of the equation, y1 equals x squared minus 3x plus 4, and then graph it out. And I did this in advance. I wish I could pull a graphing calculator up in the video, but mine's not working as of late. But you know, when you graph this equation, you're going to get a parabola that looks a little something like this. And you'll notice that it doesn't intersect the x-axis. It doesn't cross or touch it. So for that reason, you know, there are no x-intercepts. And anytime you have a graph with no x-intercepts, specifically a parabola with no x-intercepts, what it means is that there are no real solutions. I'll say no real solves for short, which implies that we're going to have two non-real solutions. All right, so that's how we can verify our answer to part 1. Our answer to part 1 says that they're going to be non-real solutions, and if we look at the graph is not intersecting the x-axis at all, so it doesn't have any x-intercepts, which in the grand scheme of things means that there are no real solutions, which implies that the solutions that you're going to get are non-real. All right, again, that means that your answers for x will involve the imaginary unit I, and as an added bonus, they'll be conjugates of each other. And with that, we're all done with the videos for section 1.4. As always, if you have any questions, feel free to let me know. Otherwise, thanks again for watching, and I'll see you guys soon.